Alex, I spent half my Saturday afternoon apologizing to a string of fairy lights I'd accidentally lobotomized. I was trying to build this floating backlit shelf for the den, but I got a little overeager with the power supply.
Let me guess. You plugged a dainty little 5-volt strip into a 12-volt transformer and wondered why it turned into a very brief, very expensive heating element.
It wasn't just a pop, it was a rhythmic sequence of tiny glowing deaths traveling down the ribbon like a fuse. I just stood there holding the plug, watching 20 bucks of electronics turn into a charcoal sketch.
Well, at least your shop smelled like ozone and regret. That's the true maker's cologne. But seriously, today we're talking LEDs, the bacon of electronics, as some people call them, and more importantly, how not to barbecue them.
Bacon is a fair comparison. You can wrap anything in LEDs and people will applaud, even if it's a mediocre birdhouse. But unlike bacon, if you cook an LED, it stays dead.
We've got a lot of ground to cover. We're going deep on power calculations, why your circuit breaker cares about your shop lights, and the physics of why these tiny chips are replacing those massive metal halide monsters in warehouses.
It really is a revolution. I remember the old shop lights, those big, orange-tinted sodium lamps that hummed like a beehive and took 10 minutes to warm up. If you turned them off by accident, you might as well go get a sandwich while they cooled down enough to restart. Now, I flick a switch and it's like God's own flashlight hit the workbench instantly.
And the efficiency difference is staggering. I saw a stat while researching this. A 400-watt metal halide fixture, the kind you'd see in a gym, puts out about 20,000 lumens. But an LED can do that same job with only 150 watts.
That's the beauty of it. It's not just about saving a few nickels on the power bill, though that's nice. It's the heat. In a small shop, those old lights were basically space heaters you couldn't turn off. You'd be trying to glue up a table in July, and the overheads were just melting the glue before you could get the clamps on. LEDs stay cool because they aren't trying to create light by making a wire scream with white-hot agony.
White-hot agony, is that the technical term for incandescent filaments?
Pretty much, it's just controlled destruction. LEDs are much more civilized. They're semiconductors, they use electroluminescence, basically electrons falling into little holes in the material and spitting out a photon as a reward.
Okay, Professor Tiger, let's get practical. If I'm a maker and I want to add some accent lighting to a cabinet, I can't just hook an LED to a battery and call it a day, right?
No, and that's where the tuition gets expensive. An LED is a bit of a glutton. It'll take every bit of current you give it until it literally bursts. You have to use a resistor to act like a bouncer at a club, keeping the crowd under control so the LED doesn't get overwhelmed.
So, let's talk math. I know, everyone's eyes just glazed over. But if you want to know if your project is going to trip a breaker or melt a wire, you need the formula. Power equals volts times amps, PIVI.
It's the holy trinity of shop electronics. If you're staring at a 300-watt high bay LED fixture and you're wondering if you can daisy chain 10 of them on a single 15-amp circuit, you better start doing the long division.
Right, so if we have that 300-watt fixture at 120 volts, that's 2.5 amps per light. 300 divided by 120. If you put 10 of those on one circuit,
You're drawing 25 amps. On a 15-amp breaker, that's not a lighting system, that's a smoke signal. Even on a 20-amp breaker, you're pushing your luck.
and there's that 80% rule, right? You mentioned this to me when I was wiring my craft room.
Always. If a light is going to be on for more than 3 hours, which, let's be honest, in a shop is every Saturday, you should only load a breaker to 80% of its rating. A 20-amp breaker is really a 16-amp breaker for continuous use.
That's a mistake people make all the time. They see 20 on the switch and think, I have 20 units of electricity to spend. But the breaker needs a little breathing room so it doesn't get grumpy and trip just because the compressor kicked on.
Exactly. It's about not living on the edge of the cliff. And it's not just the total load, it's the inrush. When you first flick the switch on a big bank of LEDs, the drivers, those little boxes that convert your wall power to what the LED needs, they can have a tiny little thirst for power right at the start.
Speaking of drivers, I've seen projects where people use a simple resistor and others where they use a dedicated LED driver. When do I need to stop being cheap and buy the driver?
Well, I'm the king of cheap, but even I have limits. If you're just putting a single-on light on a guitar pedal, a resistor is fine. But if you're doing something high power, like shop lighting or a high-end lamp, a driver is like having a dedicated valet for your electricity. It handles the fluctuations in your house power so the LEDs don't flicker or dim when the fridge starts up.
And the lifespan. Everyone says LEDs last 100,000 hours. But my 10-year bulbs in the kitchen seem to die every 18 months. What gives?
It's almost never the LED itself that dies. It's the cheapest dirt electronics in the base of the bulb. Heat is the silent killer here. If you put an LED bulb in an enclosed fixture where it can't breathe, it's basically sitting in a sauna until its brains fry.
So, if I'm building a custom wooden light fixture, which I know you've done, how do you handle that heat? Wood isn't exactly a great heat sink.
You have to get creative. I usually hide some aluminum channel inside the wood. The LEDs stick to the aluminum, and the metal pulls the heat away like a straw, spreading it out so the wood doesn't just bake. I once built a walnut desk lamp and forgot the ventilation. After 2 hours, the finish started smelling like a campfire. Not exactly the ambiance I was going for.
Oh, these are the smart ones. The ones where you can control every single little light individually. These are basically tiny computers in a trench coat, aren't they?
They really are. Each one has a little chip inside. But here's the trap. These things are thirsty. A full strip of these on bright white can pull several amps. I've seen people try to power 5 meters of these off a tiny little Arduino board.
And I bet the Arduino just gives up the ghost immediately.
It doesn't just quit. It gets hot enough to brand your thumb. You have to inject power. You run a heavy gauge wire along the strip and tap in every few feet, like giving the electricity a shortcut so it doesn't have to fight its way through that thin copper ribbon.
It's like a water pipe. If you have a mile-long garden hose that's only a quarter-inch wide, you're barely going to get a trickle at the end. You need to hook up a fresh spigot halfway down.
That's a perfect way to put it. People underestimate how much friction there is in a thin wire. You lose voltage over distance. If you start with 5 volts at the plug, you might only have 3.5 volts at the end of a long run. Your LEDs will start looking dim and yellowish, like they've got a bad case of the flu.
So, for the folks listening who want to start their first LED project this weekend, maybe some under-cabinet lighting or a backlit sign, what's the Tiger method for not burning the house down?
First, don't trust the labels on the cheap power bricks you find in your junk drawer. Just because it says 12V doesn't mean it's putting out a clean 12 volts. Get your multimeter out. It's the only way to know the truth.
And check your polarity. LEDs are diodes. The D stands for diode. They are one-way streets.
Right, you put them in backward and they just sit there stubborn as a mule. You put too much voltage in backward and you might punch a hole through that one-way gate and then you're back to that ozone smell we talked about.
I think the biggest takeaway here is that LEDs are incredibly forgiving of our creativity, but they're absolutely heartless when it comes to the laws of physics.
That's it exactly. They'll give you 50,000 hours of beautiful, crisp light, but they demand a steady diet and a cool place to sleep. If you respect the math, they'll outlast the furniture you put them in.
Before we wrap up, what's the one project you haven't done with LEDs yet that's still on your bucket list?
I want to build a resin river table where the river is actually a high-resolution LED display that reacts to where you put your coffee mug. But I need to figure out how to keep the resin from yellowing under the heat first.
Of course, you'd find a way to make a table even more complicated.
Hey, if it's worth doing, it's worth over-engineering until you have a headache.
On that note, thanks for joining us in the Tiger Den. Go forth, measure your voltage, and keep your resistors handy.
And remember, if the light starts turning purple and smelling like a burnt toaster, you've probably found the limit. See you next time.